Welcome to section 13.5 on binomial experiments. This is page 1. So let's talk about the definition. What does it mean to be a binomial experiment? Okay, first of all, notice bi. So think of bicycle. How many wheels does a bicycle have on it? 2, right? So binomial has something to do with 2. Let's read the first property. The experiment has only 2 outcomes, success and failure. So that's what it is. Now I want you to keep in mind that when we say success and failure, it just means it has 2 outcomes and we consider them success and failure. And it's just whatever you are interested in, you call success, and whatever you're not interested in, you call failure. Okay, so the experiment is performed for a fixed number of trials. That means you do the experiment, let's say 10 times or 20 times or 1,000 times. Part 3, the probability of success is the same from trial to trial. So basically, you're performing the experiment the same way each time. Like the first time you don't roll a die, and then the second time you toss a coin. It has to be the same thing. Probability has to remain the same from trial to trial. And then the trials have to be independent of each other in the 4th property. So meaning that the first time you do something, you can't get 1 probability. And then if you repeat the procedure and you get a different probability the second time, that's not going to work. Okay, so like when we were talking about with and without replacement, it's not going to be some kind of situation where you don't replace, because that wouldn't give you the same probability each time. All right, so let's look at some examples and see what we would consider success and failure. So if we flip a coin, so maybe your favorite side to get is heads, so you're going to call that success. Okay, so we'll say heads would be success and tails would be failure. Could flip-flop it, it doesn't matter. It's just the idea that we have a success and we have a failure. Guessing on a multiple choice quiz. Okay, so either you're going to get it correct or you're going to get it incorrect. Okay, oops. I'm going to say correct is success. That makes more sense. Okay, correct and incorrect. Okay, so rolling a die. Well, maybe your favorite number is 4. So 4 would be success, and getting 1, 2, 3, 5, or 6, let's say or 6, would be a failure. Okay, so now that's not the only way you do it. Maybe success for a problem is getting 1. It can be done different ways, but you have to categorize into 2 categories, success and failure. Testing a product. So like you have an assembly line and you're pulling products off. Maybe success is not defective. And maybe failure is it's defective. Okay, so that's the idea of 2 possible outcomes. So let's move on and talk about whether or not we think these experiments are binomial or not. So it says, determine whether each experiment is binomial. If not, explain what property of the binomial experiment fails. So they are talking about these 4 properties here. All right, if we roll a pair of dice 3 times and observe whether a total of 8 is observed. Okay, or is obtained. Okay, so think about you roll the die and think about what happens. Suppose that you have 1 on one die and 2 on the other. Well, when we add them together, we would get 3. So that would be considered not 8, so that would be considered a failure, right? Suppose we roll the die and we get a 3 and a 5. Together that is 8. That would be considered a success. Okay, so either we get a total of 8 or we don't. So we would answer this as yes. All right, the experiment performed, is it the experiment performed for a fixed number of trials? Well, let's see, what did they say we were doing? We were rolling 3 times. Okay, so that's a fixed number. We'll say yes, we'll say 3 times. And maybe up here we'll say either the sum is 8 or the sum is not 8. Okay, so we're supporting it here. The probability of success is the same from trial to trial. Every time we're rolling 2 die, and every time we have the same probability of getting a total of 8. So we would say yes. The trials are independent of each other. Well, if we roll 8 the first time, does that affect us rolling 8 the next time? No, when we roll die, they're fair, and one outcome does not affect the other. So we would say yes again. And is this a binomial experiment? Well, all 4 of the properties checked out, so yes. All right, so I want you to try. I've got a couple problems for you to try for classwork, so go ahead and pause the video, do those classwork problems, and then I want you to come back, but I want you to search for, while the video is paused, search for this. Remember your homework assignment sheet? Go ahead and find that, because we will be needing this table that's here. So if you can't find this, you can go online to Canvas, and if you look up on the home page, you'll see at the very bottom, scroll to the bottom, you'll see that there's the syllabus and the homework assignment sheet. So you can print out the homework assignment sheet or just pull it up on your computer or your phone, whatever, so that you have access to this. It's also in your book. I think the back of your book. I don't have the book right now with me, but I'll look while the video is paused. Okay. So go ahead and pause the video and then come back. All right, hopefully you located everything, and we're going to talk about computing binomial probabilities. So in a binomial experiment with n trials, so that means you've done the experiment a certain number of times, the probability of success is represented by this little p. Then the probability of exactly k successes is given by. So they mean, suppose you perform the experiment 100 times. Suppose the probability of success is, I don't know, 0.2 or 20%. And they want to know what's the probability of getting out of those 100 trials, maybe, I don't know, let's say 85 successes, okay? So here is the way we represent all of this, okay? We say binomial here, probability, and the first thing you write down is the number of trials. The second thing you write down is the number of successes. The third thing you write down is the probability. Here is the formula. Now, we're actually not going to use the formula to do all the calculations. We're going to use that table I told you to locate, all right? So go ahead. We're going to go on to page 2. So you're going to pause the video, or you're going to get a new video. So if you didn't find, if you didn't get your table before, get your book. And we'll talk about it on the next page. Bye-bye.